Imagine a world where one of the most basic facts of science is suddenly up for debate. Believe it or not, in the 21st century, there are communities of people passionately arguing that the Earth is not a globe, but a flat disk. It sounds unbelievable, almost like the plot of a science fiction movie, yet thousands of people today genuinely believe our planet is a kind of cosmic plate. They gather in online forums, hold conferences, and create countless videos to defend their alternative science about the shape of the world. Why do they believe this in the face of so much evidence? And could there be something we can learn from them, even if they are completely wrong? It is easy to dismiss this crowd as simply ignorant or foolish, despite rejecting evidence that, to the rest of us, is practically staring us in the face. Many of these skeptics are not unintelligent or crazy. To understand them better, let us start by laying out exactly what these advocates claim. What does a flat world look like, according to those who insist our planet is something like a giant pancake instead of a globe? You might be surprised to learn that they do not all agree on one single model of a flat plane. However, the most popular version, the one you will see at conferences and on websites devoted to this idea, is that Earth is a disk. Imagine a dinner plate or a pancake, round and flat. At the very center of this disk is the North Pole. Meanwhile, what we think of as the South Pole, Antarctica, is not a single point on the bottom of a globe, but instead runs around the edge of the disk. In other words, Antarctica, in this model, is like an ice wall ringing the outer rim of the world. This wall of ice, they say, holds in the oceans and prevents people, or the oceans themselves, from falling off the edge. In this disc-shaped layout, all the continents are arranged around the center. If you have ever seen the logo of the United Nations, it actually looks somewhat similar to how these mapmakers present the world, with the North Pole in the middle and the continents spread around it. Interestingly, believers in this map often point to things like the UN flag, as if the truth is hidden in plain sight. Of course, the real reason the UN emblem looks as it does is because it is a projection of the globe onto a flat circle, but these groups interpret it differently. Not everyone in this community sticks strictly to this single pole model. Some have proposed a so-called bipolar version. In that scenario, both the North Pole and the South Pole are on the surface of the disk, with some complex arrangement of continents between them. This is a less common view, but I mention it to highlight that within this alternative geography, there are debates and different schools of thought, much like in any other community, except in this case, they are debating different ways to have a flat world. There is even a minority who suggest that the Earth is not a finite disk at all, but an infinite plane that just goes on and on. Picture an endless expanse of land in all directions, possibly with other regions or worlds out there beyond the known areas. It is a pretty wild idea, and it raises its own questions. For instance, what about the sun in that scenario? Would there be multiple suns over different areas? But again, that is not the mainstream. Even within this fringe, most supporters of the flat model favor the simpler disk with a central North Pole and an ice wall at the edge. Now, if Earth is a flat disk, what about everything else? What about gravity, the sun, the moon, the stars? Proponents of this picture have a whole set of explanations for those as well, though as we will see, these explanations create as many problems as they attempt to solve. Let us start with gravity. On a round Earth, we are taught that gravity is the force that pulls objects toward the center of the planet. That is why things fall down, toward the ground. On a globe, down is basically toward Earth's center from wherever you are, which means gravity pulls toward the center of the sphere. But on a disc-shaped world, if it were simply a slab of rock floating in space, how would gravity work? If we were just a disk, the mass of that disk would still pull things toward the center of mass, which in a large disk would actually pull more toward the middle of the disk, not straight down everywhere. It would be a weird situation where gravity might feel stronger in the center and would pull at an angle toward the middle if you were near the edge of the disk. Supporters of the flat model recognize this problem. So many of them decide to throw out the idea of gravity altogether. which is quite a bold move, to say the least. Instead of the usual gravity we learn about, a common flat Earth explanation is that what we experience as gravity isn't a pulling force at all, but rather the effect of the Earth accelerating upward. Yes, you heard that right. They say the flat Earth disk is accelerating straight up, like an elevator that's constantly speeding up. If you've ever been in a quickly moving elevator, or in a car that presses you back into your seat when it accelerates, you know that acceleration can make you feel a force. In physics terms, acceleration can mimic gravity in certain cases. This is related to Einstein's equivalence principle, interestingly enough. So the claim here is, the Earth is accelerating upward at 9.8 meters per second squared, which is the acceleration due to gravity we feel on Earth. This upward acceleration gives us weight. We're being pressed against the Earth from below as it rushes up to meet us. Imagine standing in that forever accelerating elevator. You would feel pressed to the floor. That's supposedly like us standing on a perpetually accelerating flat Earth. Now, immediately, there are some obvious questions. First, how could the Earth be accelerating upward forever? Wouldn't it eventually be going fantastically fast, even approaching the speed of light? Flat Earth believers have answers. Some invoke something like dark energy, or a continuous driving force that keeps the acceleration going. Others might not worry about the mechanics too much, just saying, it's always been accelerating, so we always feel gravity. For the sake of argument, let's grant them this magical acceleration. Even then, there's a problem. If the Earth is accelerating upward to create this feeling of gravity, what about the sun, moon, and other things in the sky? Wouldn't the Earth eventually catch up to the sun or crash into the moon if it's constantly moving up? Flat Earth theorists patch this hole by asserting that the sun and moon, and the stars, are also located above the Earth, and somehow they too are moving in sync with this accelerating disk. In other words, the whole system, Earth, sun, moon, and stars, is like one big platform or elevator, all accelerating upward in unison. This is obviously an ad hoc idea, meaning it's made up just to explain this specific problem. There's no independent evidence that the entire universe is accelerating upward, except that they need it to explain away gravity on a flat Earth. Even if we accept this idea of upward acceleration as a substitute for gravity, there are further issues. On real Earth, the strength of gravity actually isn't exactly the same everywhere. It varies slightly from place to place. For example, gravity is a tiny bit weaker at the equator than at the poles on our globe, partly because of Earth's rotation, and also because the Earth is not a perfect sphere. It bulges at the equator. These differences have been measured by sensitive instruments and are well documented. If gravity on a flat Earth is just the whole disk accelerating upward, then this acceleration would have to be uniform everywhere on the disk. You'd expect gravity to feel exactly the same no matter where you are. But in reality, there are measurable differences. Flat Earth proponents often aren't aware of these subtleties, or they might claim those differences are too minor or some kind of measurement error. However, even minor variations are significant evidence when you're trying to fine-tune a scientific model. It's one more thing that the flat model doesn't naturally explain, but the globe model does without breaking a sweat. Okay, so gravity is one challenge for a flat world model. Now on to the sun and moon. On the round Earth, we know the planet rotates once per day, giving us day and night, and it orbits the sun once per year, giving us seasons, while the moon orbits Earth roughly every month, producing moon phases and eclipses. People who deny the globe obviously do not agree with the part about Earth rotating or orbiting the sun. In their view, the ground under our feet is stationary. So how do we get day and night cycles, or the changing seasons, or the phases of the moon? Their answer is that the sun and moon are not distant objects that we travel around, but rather relatively small lights that move in circles above the Earth. Think of the sun and moon like spotlights or lamps hanging above a big table, with the table representing the flat planet they imagine. The lights move around, illuminating different parts of the surface below as they go. When the sun is overhead in your area, it is daytime. When it moves away to another area, you are in night. Supporters of this idea often picture the sun and moon moving in circles around the North Pole at the center of the disk, somewhat like the hands of a clock. You can find diagrams from this community that show the sun as a small light, tracing a circular path above the world. In this framework, the sun is much smaller and much closer than it is in the conventional astronomical model. Followers of this alternative cosmology might say the sun is only a few thousand miles above the surface rather than tens of millions of miles away, and perhaps only a few dozen miles across instead of the enormous ball of gas described by standard physics. By shrinking the sun and bringing it closer, they attempt to explain why it only lights up part of the Earth at a time. They often describe it as a kind of spotlight, with its light being somewhat directional, illuminating just a certain area, and as it moves, the lit area moves too, causing sunrise and sunset as the edges of this moving beam sweep over us. However, making the sun small and close leads to more puzzles. For one thing, if the sun is literally circling a few thousand miles above a flat surface, would we not be able to see it even when it is on the far side of the disk? On a level plane, if you stand on one end of a huge field and there is a lamp at the other end, you might still see the glow from far away, assuming nothing blocks your view. Advocates of the flat model say that perspective and atmospheric effects cause the sun to appear to set. In their description, it gets too far and too low from your viewpoint, and eventually it vanishes beyond the limit of your sight, which they equate to the horizon. It is true that the atmosphere can obscure things, distant objects fade, and the lower part of a distant ship gets harder to see because of haze and refraction. But the optics do not really match a clean sunset. Think about what we actually see. The sun remains roughly the same size in the sky throughout the day. Then near sunset, it approaches the horizon and gradually disappears behind it. If the sun were a small ball moving away over a flat plane, we would expect it to get smaller and smaller as it receded into the distance and eventually fade out when it is too far away. That is not what we observe. The apparent size stays pretty constant until the sun is very low. Then it sinks below the horizon line. It does not shrink into a tiny dot. It stays a big glowing disk that gets cut off from the bottom upward by the horizon, which is Earth's curvature blocking it. That behavior is very hard to reconcile with a world shaped like a plate. Defenders of the flat scenario have to invoke some combination of perspective and refraction to try to explain it. Yet those explanations fall short of matching what we actually see. Then there is the issue of seasons. On a globe, seasons happen because Earth's axis is tilted, so each hemisphere gets more direct sunlight at different times of year as we orbit the sun. How do people who insist on a flat layout explain seasons with a sun that circles above the surface? They imagine that the sun's circular path changes diameter over the year. At some times of the year, the sun moves in a smaller circle closer to the North Pole. That would correspond to when it is summer in the northern hemisphere, because the sun is more directly above those latitudes. At other times, the sun moves in a larger circle toward the outer regions. That would be when it is summer for the southern areas and winter in the north, because now the sun is farther from us. So they try to replicate the effect of the axial tilt by changing the radius of the sun's path. It is a bit convoluted, but that is their story for the seasons. Even if you accept that scheme for a moment, it does not handle certain observations very well, such as the midnight sun in the Arctic or Antarctic, where the sun stays above the horizon for 24 hours in the local summer. In reality, near the North Pole, the sun can be visible at midnight for part of the year, and near the South Pole, the same happens during its summer. On a disc-shaped world, especially one where the sun circles around near the North Pole, getting sunlight to the far south for a full 24 hours is extremely awkward. Maps and sun paths used by this movement struggle to reproduce those observations without breaking something else in their model. What about the moon? According to this cosmology, the moon is also a small object moving above the surface, and some claim it is self-luminous. They say this to argue that moonlight is fundamentally different from sunlight. For instance, you will sometimes hear a devotee claim that moonlight is cold. They will say things like, "Moonlight makes things cooler," which comes from misreading a basic experiment where shade is warmer than exposure to the open night sky. It is not that moonlight cools objects. It is that the night sky is cold and an object radiates heat to that cold sky. People in this camp often reject the idea that the moon is reflecting the sun's light. In their explanations, lunar phases are caused by some property of the moon itself, maybe a translucent quality, or by some unseen object partially obscuring it. None of these ideas have any supporting evidence. They are simply guesses made to fit the picture. Lunar eclipses are an even bigger problem. A lunar eclipse happens when we see the Earth's shadow darken the moon during a full moon. On a spherical planet, this occurs when Earth is directly between the sun and the moon, and the planet's round shadow falls on the lunar surface, creating that curved edge that slowly moves across the moon's face. If the world were truly a flat disk, what would be creating that curved shadow? The disk itself cannot do it in the way we see. A disk would cast a flat, straight edge in most orientations, and in the scheme promoted by these groups, during a full moon, the sun and moon are both above the surface, so the planet is not actually between them. To try to fix this, some supporters of the flat picture have suggested there is a mysterious third object, sometimes whimsically called the shadow object or anti-moon, that occasionally passes in front of the moon to cause eclipses. This object is invisible to us most of the time, very conveniently, and only reveals itself by creating an eclipse. This is a prime example of how far one has to go to make a flat Earth-style model fit reality. You literally have to invent invisible celestial bodies that no one has ever seen, just to explain phenomena that are simply and predictably accounted for by a spherical planet. If we had more time, we could dive into countless other things that become nearly impossible to explain if you insist the world is a plane. For example, the motions of the other planets in the sky are a serious challenge. People in this movement mostly ignore the planets or say they are just lights in the sky without offering much detail, or consider why we do not have any credible photographs of the supposed ice wall at the world's edge, despite many expeditions to Antarctica. Those who doubt the globe sometimes claim that travel to Antarctica is restricted by a giant conspiracy. In reality, plenty of scientists and even tourists go there under regulated environmental guidelines, and no one encounters a towering barrier or a literal drop-off. There is also the question of how GPS satellites or satellite television can work if there are no satellites at all. Some individuals in this community insist satellites are fake and that all data comes from ground towers or high-altitude balloons. That story does not explain how you get global coverage in the middle of the oceans. The list of challenges goes on and on. The bottom line is that to make a flat Earth-style model that even begins to match what we observe, you have to introduce a lot of strange assumptions and complex workarounds that ultimately do not hold up very well. It is a bit like trying to patch a leaking ship with band-aids. Cover one hole and another leak starts. There were good reasons why humanity, as far back as ancient Greece, moved on from the notion of a flat world. The spherical Earth model is not some arbitrary dogma. It simply matches reality far better, with far fewer contortions needed. Now, at this point, someone skeptical might wonder if these people are actually for real. It is tempting to think they are all pulling an elaborate prank or just being contrarian for the sake of it. Indeed, a few individuals probably do pretend to believe in wild ideas just to be edgy or to mock others. There is even a running joke on the internet about people claiming to believe in a flat world, ironically. For example, some users play devil's advocate on forums just to stir the pot. But for the most part, the core community that promotes this picture of the world really does believe what it is saying. They are very serious about it. They spend a lot of time researching, though much of that research is watching online videos made by like-minded creators or conducting small experiments that they interpret within their own framework. Many have spent their own money on experiments or projects to prove that the Earth is not a globe. Some have built homemade rockets or sent up weather balloons with cameras hoping to see a completely flat horizon. Some buy expensive equipment, like a $20,000 fiber optic gyroscope, to test whether the planet is rotating. If it were all a joke, it would be a very committed joke that involves significant personal investment and risk. A telling sign of their sincerity is that most flat earthers are fully aware that the majority of people, including their own friends and family, will think they've lost their minds. To publicly declare, "I believe the earth is flat," is to invite ridicule and social stigma. Yet they do it anyway, which suggests they truly have convinced themselves. It takes a certain level of conviction, or maybe stubbornness, to hold on to a belief that makes you an object of widespread mockery. It's not the kind of thing most people would do just for laughs. So I think we have to accept that the typical flat earther is genuine in their belief. Now, it is true that flat earth ideas often go hand in hand with other conspiracy theories. If someone is convinced that our planet is not a globe, they might also believe that NASA is lying about space, that the moon landing in 1969 was faked on a movie set, that satellite photos of Earth are all CGI fabrications, and that there is a massive cover-up involving scientists, pilots, engineers, and governments worldwide to conceal the supposed truth about the shape of our world. They might also reject other scientific consensuses. For example, some express doubt about things like evolution, climate change, or vaccine safety, since once you are in a conspiratorial mindset, it often extends to many domains. However, labeling everyone in this scene as nothing but crazy conspiracy nuts might be an oversimplification. Yes, there is a conspiratorial mindset there, by necessity, because to insist that our planet is a disk, you have to believe that literally generations of people, from sailors to astronauts to scientists to teachers, have either all been fooled or are all in on the deception. It is arguably one of the biggest conspiracy ideas imaginable, but many people in this community would not have described themselves as conspiracy theorists before they fell into this rabbit hole. Some might start off simply as skeptics, asking questions like, how do we know for sure the Earth is round? Have I personally seen the curvature or the globe from space? And then slowly falling deeper into alternative explanations as they find the standard answers unsatisfying, or they encounter charismatic promoters of this story online. To understand why someone would go that route, it helps to look at a bit of the history of this movement and the philosophy behind it. The modern form of the claim that Earth is not a globe traces back to the 19th century. One of the key figures was an Englishman named Samuel Rowbotham. Back in the 1800s, Rowbotham conducted experiments that he believed proved our world is not curved. The most famous was his experiment on the Bedford Level, a straight 6-mile stretch of canal in England. He stood at one end of this long waterway with a telescope at a certain height above the water and had someone hold a flag at the same height 6 miles away. He reported that he could see the flag the whole way, which, according to him, would be impossible on a curved Earth, because the curvature would have put the far end a few meters below the line of sight. In reality, his experiment was flawed. Later attempts showed that refraction of light in air can allow you to see farther than the pure geometry would suggest, and when the test is done more carefully, you do see the effect of curvature. But Rowbotham was convinced by his own observation. He subsequently published pamphlets and a book called Earth Not a Globe, and spent decades promoting this unconventional picture of our planet. Rowbotham was not just making observations, he was also pushing a way of thinking that he called zeticism. This word comes from the Greek zeteo, meaning to seek. Zeticism, as Rowbotham described it, is a kind of extreme empiricism, meaning that you should only trust what you can directly observe and experience for yourself. In his view, if you want to understand the world, you should start from your own senses and not accept anything you cannot personally verify. On the face of it, that might sound somewhat similar to the scientific method, because science does value experiments and observations. But Rowbotham took it to an extreme that actually runs counter to how science must operate in practice. He basically dismissed a lot of established science as theory or hearsay, because he personally did not witness the evidence. For example, you or I might say, we know the Earth is round because we have satellite photos, and we can fly around it, and physics predicts it, and so on. Rowbotham and modern followers of this view would reply, Have you personally seen the curvature? Have you personally gone to space? No? Then you are just trusting someone else's word or some institution's story. That is the Zetetic philosophy. Trust only your own direct experience. Now, here is the thing. People who hold this belief today still preach this philosophy. If you go to one of the main websites dedicated to a non-spherical Earth, or listen to prominent advocates of a level world, you will hear the same kind of language. They will say, essentially, the world looks flat, does it not? The ground under your feet is flat. The clouds up there have flat bottoms. The horizon looks flat, and always at eye level. Those are all examples of your senses telling you the Earth is flat. This is the empirical approach, going by what you can observe yourself. They frame it as a kind of return to common sense and claim that the idea of a globe is something we are taught to believe despite what our eyes show us. It is almost like they are saying, who are you going to trust, the textbook or your own eyes? This insistence on personal observation as the only reliable evidence is crucial in understanding their perspective. It is not that the people in this scene have absolutely no evidence. It is that they have defined what counts as evidence in such a narrow way that they exclude anything not directly witnessed by themselves or by people they consider trustworthy. It is like putting on blinders. They ignore enormous swaths of knowledge because they label it unverified from their personal standpoint. After Rowbotham died in 1884, others carried on his work. In the mid-20th century, an Englishman named Samuel Shenton created a group he called the International Flat Earth Society around 1956. Shenton tried to keep the idea alive just as the space age was kicking off. Famously, when asked about photographs from orbit showing Earth as a sphere, he said something like, "It is easy to see how a photograph like that could fool the untrained eye." In other words, he assumed those images were fisheye lens distortions or outright fakes. Belief in a non-spherical Earth survived through a few individuals, and in the 1970s, an American, Charles K. Johnson, ran that society and amassed a small following via newsletters and mail correspondence. However, through the late 20th century, people who held this view were very few in number. We are talking maybe in the low thousands globally, and they were mostly isolated cranks as far as the public was concerned. The real explosion of this Earth as a disk movement came with the rise of the internet and social media, especially YouTube in the 2010s. In the early years of that decade, you start to see more content online that questions the globe, but around 2015 and 2016, it went viral. A few devout believers produced videos that were easily accessible and even somewhat slick in presentation. Things like 200 proofs Earth is not a spinning ball, or a series of clue-style videos about how our planet supposedly is not a sphere. These productions strung together a bunch of misunderstandings and alleged anomalies and presented them in a way that could seem persuasive to someone who did not know the counter-arguments. Through YouTube's recommendation algorithm, people who watched one conspiracy-themed video might get suggested a video about a flat world next, and down the rabbit hole they went. By the late 2010s, millions of people had been exposed to content promoting this narrative. The effect was seen in surveys. For example, a poll in 2018 found that about 2% of Americans firmly believed the Earth is flat. 2% might sound small, but in a country of around 330 million, that is on the order of 6 or 7 million people, which is not negligible at all. The same poll indicated that a few percent more were unsure or believed it in some lesser degree. What was particularly notable is that the percentage of younger people, especially millennials, who entertained this kind of idea was higher than that of older people. One interpretation is that younger folks, who get more of their information from YouTube and social media, were more likely to come across these claims or to question the standard narrative. In any case, reliable numbers are hard to pin down, but it is clear the movement grew dramatically in the 2015 to 2020 period. We went from maybe a few thousand fringe believers to likely tens of thousands or more in the Western world who at least think the claim has some merit, not to mention in some countries where it caught on strongly, with reports of groups promoting a flat world in places like Brazil and various other regions around the globe. Ironically, around the globe. So how does someone come to reject something as scientifically well established as the round Earth? As we have touched on, there is not a single reason. It is often a cocktail of factors. Some followers of this belief find the idea appealing for religious or spiritual reasons. They might interpret religious texts as suggesting a world shaped like a disc with a dome above it and think that the scientific globe model contradicts Scripture. Others are generally suspicious of government and authority, and since NASA is a government agency, they lump the globe in with things the government supposedly lies about. In the age of information and misinformation, distrust in institutions can run high, and some have come to believe that everything is a lie, from medical science to historical facts to, yes, the very shape of the Earth. Most people in this circle will tell you that they see themselves as skeptics. They believe they are doing what any good critical thinker should do, not accept a claim until it is proven. One quote from a conference devoted to this worldview that stuck with me was along the lines of, "I became convinced when I realized I could not prove the Earth's roundness to myself." That is, a person went looking for evidence of the globe and, not finding what they personally felt was undeniable proof, started questioning the whole thing. Now, there's an important subtlety here. In science, strictly speaking, you never prove things absolutely. You gather evidence that supports a theory or refutes a hypothesis. Proof is for mathematics. But in everyday language, we say prove to mean show beyond a reasonable doubt with evidence. When a flat earther says they want proof the Earth is round, they mean they want something they themselves can see or measure that convinces them. However, the problem flat earthers have is that they cannot do many of the observations or experiments by themselves, at least not easily, or without specialized equipment or knowledge. So if you buy the idea that only personally collected evidence counts, then by definition, you're going to have to throw out an enormous amount of knowledge. No individual can personally verify everything. And the things that one can verify personally, like observing ships or doing a backyard experiment, they often interpret incorrectly or find inconclusive. It becomes a situation where their philosophy forbids them from accepting the mountains of evidence that do exist because they didn't personally gather that evidence. Needless to say, if you want to hold on to a belief, it helps if you set conditions that make it impossible to shake that belief. If a flat earther says, "I'll believe the Earth is round when I can see it with my own eyes from space," they've set a bar that 99.999% of people will never meet. Most of us will never go to space. And even if you point to pictures from space, they'll say, "I don't trust those, they're CGI." You might point to testimony from astronauts, they'll say, "They're lying or brainwashed." You point to satellite data or communications, they'll suggest alternative explanations. So in a way, they insulate their belief system by refusing to acknowledge any evidence that comes through what they consider second-hand sources. What's interesting, though, is that their application of skepticism is inconsistent. A flat earther will readily watch a YouTube video made by a fellow flat earther and accept it at face value as evidence, even though that is actually second-hand information for them. If someone on YouTube says, "I did this experiment and got this result," a viewer is taking it on faith just as much as if they read in a science book that someone did an experiment. But flat earthers trust those who are saying what they're inclined to believe. This is a human tendency. We are more likely to trust sources that tell us what we want to hear or what fits our existing narrative. It's confirmation bias. They have, in effect, replaced trust in scientific authority, which is based on a huge collective process, with trust in alternative authority, like a charismatic YouTuber or community consensus within their group. So, what's wrong with flat earthers' attitude? After all, asking for evidence sounds like exactly what a rational person should do. The devil is in the details. Yes, evidence is key to scientific progress, but flat earthers' philosophical approach by which they reject huge categories of evidence, is ultimately flawed. The distinction they try to draw between evidence you collect yourself and evidence someone else collected is not as clear-cut as they think. In reality, all evidence we have is through our senses at some point. If you read about an experiment in a textbook, your eyes are seeing the text. That's your sense at work. If you watch a video of someone performing an experiment, you are indeed getting sensory input. You saw something happen on screen. You heard the person explaining it. Now you might say, well, that could be fake or incorrect. I didn't do it myself. True, but that's why science doesn't rely on one person's word. Experiments are repeated and verified by many independent parties. Think of something like the existence of atoms. None of us has actually seen an atom with our naked eyes. They're far too small. We accept that matter is made of atoms because a vast body of experimental evidence from many people over decades points to that conclusion. From chemical reactions always combining in fixed ratios, to imaging techniques like scanning tunneling microscopes that can produce images consistent with atoms, to atomic theory successfully predicting countless phenomena. Even if you personally have never seen an atom or done those experiments, you trust it because the system of science has proven reliable. If atoms weren't real, a lot of technology, like computer chips or nuclear power, wouldn't work as it does. The proof is kind of in the pudding. Reality works in a way consistent with atomic theory, which is why we trust it. Now let's use a more everyday analogy. Consider going to the supermarket and buying a canned soup. Do you have evidence that what's inside the can is safe to eat? You can't see it. The can is opaque. You didn't personally cook it. You probably don't know the people who made it. Yet, most of us will eat it without too much worry. Why? Because we have indirect evidence. We know, from our own experience and societal knowledge, that there are regulations, quality controls, and consequences for food poisoning outbreaks. We likely have eaten canned food many times without incident. Our personal senses didn't directly verify the contents ahead of time, but we trust a whole infrastructure that ensures that food is edible. That trust is not blind. It's based on evidence we've gathered through life, seeing brands and safety seals, maybe hearing of the rare recall, which shows that when something's wrong, it gets corrected, and so on. It's similar with science. Most of us don't personally launch satellites or calculate orbital mechanics, but we use a GPS app that tells us our location, and it works to within meters or better. That system relies on satellites in orbit and the physics of around Earth, including adjustments for Einstein's relativity, because time runs slightly differently on those fast-moving satellites high above Earth's surface. If the Earth were flat, or if physics as we know it were wrong, GPS would not work as superbly as it does. Every time you use GPS, you're leveraging the fact that the Earth is a globe and that science has accurately described how things move around it. You might not see the satellites, but the consistent functionality of such technology is evidence that the system knows what it's doing. Another example. Consider air travel. Airplanes fly long-haul routes on schedules that simply wouldn't make sense if the Earth were flat. Pilots and navigators use calculations assuming a globe. The fact that you can fly from, say, Sydney to Santiago in a time that matches what globe-based calculations predict, and not in some drastically longer time that a flat Earth map would entail, is indirect evidence that the Earth is round. Most passengers on that flight won't think about the geometry involved, but they trust that the pilots know what they're doing, and the pilots trust the training and maps and physics they learned. The point is, we all rely on evidence that science works without personally reproducing all of science from scratch, and that's okay. That's how a society functions and progresses. Flat earthers claim that they are leading a scientific argument by re-questioning Earth's shape is misplaced. There really is no scientific debate among experts about the Earth being round. That was settled long ago through exactly the kind of evidence and reasoning processes I described. Instead, the flat Earth debate is more about whether one should trust evidence collected by others or trust the collective processes of science. Flat earthers have essentially said, no, we start from zero. But ironically, even they don't start entirely from zero. They pick and choose bits of modern technology and knowledge to use. They'll use cameras, computers, lasers, all products of science they otherwise claim is false. They just reject the conclusions that they don't like or that conflict with their interpretation of what my senses tell me. This is why I think scientists should take the flat Earth phenomenon seriously. Again, not take their claims seriously as in thinking they might be right, but take the fact that people believe this as an important sign. It's a dramatic example of a broader issue: trust in science and understanding of how evidence works. As our scientific knowledge grows ever more advanced and specialized, it becomes harder for an average person to see all the evidence firsthand. We can't all have particle accelerators to verify every particle physics discovery. We can't all launch rockets to check the shape of Earth. We have to have some level of trust in the scientific community. If that trust erodes, we could see more movements like flat Earth, or others that could be more dangerous, like a refusal to trust medical advice or public health measures. Flat Earthers, in a sense, are a warning sign. They're saying, we don't trust you. We want to verify everything ourselves. While their conclusions are wrong, the fact that such a desire exists means the scientific community needs to address it. We need to better communicate not just the facts of science, but the process of science, how we arrive at knowledge, how evidence is tested and cross-checked, and why some sources of information are more reliable than others. For instance, one could engage curious, flat Earth-minded folks in doing actual experiments that are within reach. There are educational projects where students from around the world collaborate to measure shadows and recreate Eratosthenes' experiment, demonstrating Earth's curvature. There are amateur high-altitude balloon kits where you can send up a camera and see for yourself the curvature from, say, 100,000 feet. It's subtle but visible. Things like Foucault's pendulum, which shows Earth's rotation, can be set up in a museum for people to see with their own eyes. By providing these experiences, we make the evidence more personal and perhaps satisfy some of that zetetic itch for direct empiricism. At the same time, we should help people understand that trusting reliable sources is not a weakness or folly. It's a necessary part of living in a complex society. I don't think twice about using a laptop or smartphone, even though I couldn't build one from scratch or explain every component's working principle. But I know thousands of brilliant engineers and scientists collectively can, and I benefit from that. There's a phrase, standing on the shoulders of giants, which is how Isaac Newton humbly described his accomplishments. He built on the work of those before him. Flat earthers almost seem to want to knock everyone off the giant's shoulders and start again on the ground. The result would be that progress grinds to a halt, and each person or generation wastes time rediscovering things that were already known. Imagine if every pilot insisted on remeasuring the Earth's shape before every flight. No plane would ever take off. That's why we accept certain things as given, because they've been established beyond reasonable doubt, and it frees us to move forward. In summary, the Earth is undoubtedly round, an oblate spheroid, to be precise. The flat Earth idea is wrong on countless levels, observationally, experimentally, theoretically. But the people who believe in it demonstrate how someone can get drawn in by the allure of being a lone truth seeker in a world of supposed deception. They're wrong, but not necessarily stupid. Many are perfectly capable of understanding the science. They've just been led to deeply distrust it or misunderstand it. Some even have a decent grasp of certain scientific concepts, but they apply them selectively or misinterpret them. By looking at why flat Earth science is wrong, but not stupid, we're reminded that even smart people can be misled if they lose trust in the scientific process or lack a complete understanding of it. It underscores the importance of science education that emphasizes critical thinking and an appreciation for why the scientific consensus on some things is as strong as it is. As a science communicator, I also take it as a personal lesson. Never assume that a fact is too obvious to explain. For a long time, educators might have thought, oh, everyone knows the Earth is round, We don't need to dwell on that. Yet here we are, having to explain basic astronomy and physics because a segment of people missed it or doubted it. It shows there's value in teaching not just what we know, but how we came to know it, even for things that seem basic. Before we close, let's dispel any lingering doubt. No, you will not fall off the edge of the Earth, because there is no edge. It's a globe. If you travel far enough in one direction, you'll end up coming back to where you started, assuming you can find transport over the oceans and so forth. Countless navigators, explorers, and now astronauts have verified the globe's reality. The knowledge has been solid for centuries, so you might wonder, is it even worth arguing with a flat earther? For hardcore believers, perhaps not. Once it's a matter of identity, it's tough to turn someone. But for those on the fence or merely curious, I believe it's absolutely worth providing the explanations and evidence. Some people have actually been saved from falling into the flat earth rabbit hole by clear, patient science communication. That makes it all worth it. In the end, confronting flat earth ideas isn't just about a quirky conspiracy theory. It's about how we as a society deal with information, trust, and truth. The rise of flat earth belief is a symptom of a deeper issue. People feeling alienated from or skeptical of the scientific establishment. The cure is not ridicule, but engagement, education, and yes, a bit of empathy. We should encourage the spirit of curiosity and skepticism, but guide it so that it doesn't veer off into rejecting reality itself. So, the Earth is not flat. Let's make that clear. But the story of flat earthers has given us a lot of food for thought. It reminds us that our collective understanding of truth is only as strong as our communication and trust. In a way, we should thank the Flat Earth movement for highlighting cracks in how some people receive scientific knowledge. By addressing those, we can improve science communication for everyone. To wrap up, the Flat Earth movement is a mirror that reflects some challenges in our modern information landscape. It shows how easily facts can get overshadowed by narratives that appeal to emotion or intuition. It's a cautionary tale, but also an opportunity. If we can understand and address why some people reject even the curve of the Earth, we might be better equipped to handle the spread of misinformation in general. In the spirit of constructive dialogue, if you ever meet someone who genuinely thinks the Earth is flat, you don't have to agree with them, and you shouldn't. The evidence is overwhelmingly against them. But try to understand what led them there. Was it a distrust of authority? A bad experience with education? A community that gave them a sense of belonging? Knowing that, you can have a more meaningful conversation. Maybe you won't change their mind, but others listening in, those who are curious but not yet convinced, might hear something that leads them to reconsider. At the end of the day, we all want to understand the world we live in. That's what science is really about. Human curiosity and the drive for understanding. Flat earthers have that drive. It's just misdirected. Our job, as people who care about truth and science, is to help redirect that curiosity back toward productive, reality-based paths. Because the real world, the round world, is an amazing place, far more fascinating than the flat earth myth. And when we all share a common understanding of basic truths, we can get on with exploring the truly intriguing mysteries of the universe, of which there are plenty. The Earth isn't flat, but ignorance and mistrust can spread and flatten the progress of knowledge if we're not careful. By taking the flat Earth science seriously as a social phenomenon, we're reminded to keep our communication down to earth, pun intended, and ensure that no one gets left behind, stuck on a mental island of misinformation. In the end, I remain optimistic. Knowledge and truth have a way of lighting up the darkness, much like the sun inevitably brings dawn to every corner of our round earth, and that's a cycle you can trust every single day.